In this video, we're going to work example problems where we're given an integral and we can solve that integral by making a substitution that ends up turning the integrand into a rational function, a rational expression. And we know that once we have the integral of a rational function, we can solve it. The last 3-4 videos, we went into thorough depth on solving pretty much any kind of rational function. In the previous few videos, we went into thorough depth on finding the integral of any kind of rational function. And so if we have an integral that we can't figure out how to solve it, but we can make a substitution that turns the integrand into a rational function, then we've pretty much solved it because we can find the integral of any rational function. Okay, so what we're going to do in this video for these problems is we're just going to be given an integral, and so the integral is not going to be of a rational function, but we're going to make the necessary substitution to turn it into a rational function. But then we're going to stop there. We're not going to proceed to solve the integral of the resulting rational function. We did more than enough work on this in the previous videos on that topic. Okay, and so the textbook notes that the main scenario that this comes up in is if you've got a radical in the integrand, the radical of some expression of x, some function of x. Like here we've got a radical of x minus 1, but not square root, any radical. And a lot of times if you make the substitution that, like you say, u is equal to that entire radical, so here we're going to say that u is equal to the square root of x minus 1, but if it was the cube root, we do the cube root of x minus 1. If you make that substitution, a lot of times after you simplify, you'll end up with a rational function. Now, there's other cases outside of radicals where you can do this, make a substitution and turn it into a rational function, and we'll work some of those examples in this video as well. But okay, so let's say you've looked through you've exhausted all other options. You can't figure out how to integrate this, so you see a radical and you say, okay, well, let me try saying that u is equal to that radical. Okay, and so now what we're going to do is, usually I would say let's square both sides and get u squared is equal to x minus 1 and then take the derivative from there to get a cleaner derivative. But this is a special case where we can see that du dx, if we go ahead and take the derivative here, here I see 1 over square root of x minus 1 in the integrand. So let's do this. So we've got du is equal to, and we can bring the 2 over, and so we've got, okay, so there's dx over the square root of x minus 1, but now we're going to need x. So we have u squared is equal to x minus 1. So x is equal to u squared plus 1. Okay, so making the substitution, we've got the 1 over x and then dx. Or no, we're not doing that because dx over square. So yeah, then 2 du, right? Because dx over square root of x minus 1 is equal to 2 du. And there you go. There's the rational function integral. Okay, so you look at you can't figure out how to solve this. You see a radical, so you say, okay, I'm going to say that u is equal to that radical. Now, if we take the derivative here, we get 1 over 2 root x, and I don't see any kind of form of a 1 over 2 root x. So in that's kind of the process here. You might want to consider taking the derivative at this step, but think about what the derivative is and see it. And if you don't see that form, then do this. So say u squared is equal to x, and now do implicit differentiation, and you get, so dx, the entire equation is 2u du dx is equal to 1. So 2u du is equal to dx. Okay, and so again we've got x is equal to u squared, And so, okay, we can make the substitution and get, so x squared is u to the fourth. X is u squared. Square root of x is u. Now dx is 2u du. So u to the fourth plus u cubed. There you go. That is, now you just solve that. It's a rational function. Okay, so, you can't figure out how to solve this. So, and you're dealing with a ratio, right? A fraction. And so then you see within the fraction somewhere is a radical with an x expression in it. So you can try, you say u is equal to this. Now, if I take, to me, it's going to be complicated to take this derivative right here. So let's do this. U cubed is equal to x squared plus 1 So, and we've got 3u squared du dx is equal to 2x. So 3u squared du is equal to 2x dx. Okay, and so, we can make an x dx here, right? We can do this. Yeah, so let's try that. So we've got 3/2 u squared du is equal to x dx. Okay. Do we have an x squared? Yeah, we do have x squared. U cubed is equal to x squared. Yeah, this should work. X squared is equal to u cubed minus 1. Yeah, there we go. Okay, so we've got u. X squared is u cubed minus 1. And then x dx is 3/2 u squared du. So we can take out the 3/2. U squared times u cubed plus 1 is u to the 5th minus u squared. There you go. Okay, this one's kind of tricky because, what do? U is equal to the square root of x, or u is equal to the cube root of x. And so you're just trying to end up with whole numbers. So with the substituted variable. So if we said u is equal to the 6th root of x, right? Then what? So what is u cubed? Square root of x, right? 3 times 1 over 6 is 1/2. All right, now u to the 6th is equal to x. Six u to the 5th so 6u to the 5th du is equal to dx. All right, so u cubed, or wait, no. Okay, yeah, so then, yeah, u squared is equal to the cube root of x. Right, yeah. So u cubed minus u squared, and then dx is 6u to the 5th. And that's it. Okay, so okay, there's no root here, right? But here's an example of you can think about potentially making a substitution. And so to me, if we say that u is equal to e to the x, then u squared is equal to e to the 2x, right? And then we know that du dx is e to the x, so du is equal to e to the x dx. Now we can write this e to the 2x plus 3 e to the x plus 2, and then e to the x times e to the x is e to the 2x, so we could do this, right? That's the same thing. And so what we've got is u squared plus 3u plus 2, and then u, and then du. There we go. Okay, so, I mean, to me, I don't know why yeah, we're obviously going to just do u is equal to tangent t. Therefore, du is equal to secant squared t dt. I mean, this is just an obvious u substitution. Regardless of, it doesn't matter what it turns into. And then you've got u squared plus 3u plus 2. Yeah, I don't know why that's not the best example. Because it is technically rationalizing this. We have a rational function, but I mean, I think this is you have an obvious u substitution here. But yeah, I mean, okay, this is a rational expression. Okay, so we'd have to say, I don't know what else we could substitute for. U is equal to e to the x. Du is equal to e to the x dx. Okay, so 1 plus u, and then dx is, well, e to the x is u, so this is u dx. Okay, yeah, so dx is du over u. Oh yeah, pretty cool. No, du over u. So you've got u squared plus u. Yeah, interesting. You might not be able to solve this. You can't figure out how to solve this, right? 1 over 1 plus e to the x. It seems simple, but now you can. Okay, so we'll say that u is equal to the square root of x plus 3. If we differentiate here, I don't think that's going to be helpful, so we'll say that u squared is equal to x plus 3. To u du dx is equal to 1. So 2u du is equal to dx. And then we've got x is equal to u squared minus 3. Okay, so 2u plus u squared minus 3, and then 2u du. So u squared plus 2u minus 3, 2u du. Okay, we'll say that u is equal to cube root of x. So u cubed is equal to x. So 3u squared du dx is equal to 1. So 3u squared du is equal to dx. So 1 plus u, and then dx is 3u squared, and then du. There we go. Okay, we see that radical, so let's say u is equal to the square root of x. If we differentiate here, I don't see that's how that's going to be helpful, so we'll say u squared is equal to x. 2u du dx is equal to 1. So 2u du is equal to dx. So we've got 1 plus u squared, and then dx is 2u. There we go. Okay. So when I look at this, you know, the idea is you want to substitute for the entire radical. So let's do that u, and actually this should work, because what we'll get is u squared is equal to 1. So we get what's under there, under the radical. Okay, so let's see, I'm not sure what. So 2u du dx is equal to, okay, so 2u du is equal to, okay, so I don't think we can do anything with this, so we're going to say for u root x du is equal to dx. Now root x, we can see, is equal to u squared minus 1. So for u squared minus 1 du is equal to dx. Okay, yeah, I think that should work. So we've got u, and then x is u squared minus 1 squared. Okay, and then dx is yeah, there we go. So u squared minus 1. There we go. Yeah. All right, so if we say that u is equal to cosine x, then du is minus sine x dx. Therefore, minus du is sine x dx. Okay, so we've got u squared minus 3u. There we go. Okay, so if we say that u is equal to e to the x, then u squared is equal to e to the 2x, and du is equal to e to the x dx. And so we've got u minus 2, u squared plus 1, du. Okay, if we say that u is equal to the hyperbolic sine of t, then du is equal to hyperbolic cosine of t dt. And so we've got u squared plus u to the fourth du in the numerator.